Hello friends and welcome at my channel. Today I would like to show you guys how the formulas for doubled angled are working. Okay, so sine of 2 alpha, cosine of 2 alpha and tangent of 2 alpha. So let's see how it works. So first of all, what about sine of 2 alpha? Well, sine of 2 alpha, this is basically sine of alpha plus alpha, and we prove the formula. I'll link it here. This is sine of the first angle, cosine of the second, but they are equal at this point, plus sine of the second one times cosine of the first, but they are equal still. So we have 2 sine alpha cosine alpha. The formula works. What about the cosine of 2 alpha? Well, it's the same idea. Cosine of 2 alpha, it's equal to the cosine of alpha plus alpha. This is equal to cosine of the first angle times the cosine of the second one, but they're equal, minus the sine of the first times the sine of the second. So we're having cosine squared of alpha minus sine squared of alpha. All right, so this is also very nice. You see maybe the similarity to cosine squared plus sine squared of alpha, which is giving us 1 because of the Pythagorean trigonometrical Pythagoras. Well, that's very nice to use in many cases, especially also for integration once we're gonna get so far, and I'll explain that to you as well. Okay, what about the tangent? Well, the tangent of 2 alpha once again is the tangent of alpha plus alpha, and we derived the formula last time. It was the tangent of the first angle plus the tangent of the second divided over, but now they're equal again, 1 minus tangent of the first times tangent of the second, but they're equal again. That's why 2 tangent of alpha divided over 1 minus tangent squared of alpha. Okay, so what are maybe some applications of this? Let us maybe see one example. If I have cosine of, let's say, 30 degrees, okay, do I know the value? Well, I know the value of cosine of 30. It was, oh, maybe let's take the bigger one, cosine of 60. Let's check it maybe first. So cosine of 60, we know it's a half, right? We proved that. I'll link it in the first video of trigonometry, the introduction. And well, now we are having, if we're applying this formula, the cosine of 60, this is a cosine squared of 30 minus sine squared of 30. Okay, and you may say, well, okay, I know the cosine of 60, but I still do not know the cosine of 30. So how should I be working? Well, you see, we would know that this is a half. We have cosine squared of 30. And if you remember, cosine squared alpha plus sine squared alpha, as I mentioned, is 1. So basically sine squared of alpha is 1 minus cosine squared of alpha. So I'm having minus, instead of sine squared, I'm just writing 1 minus cosine squared of 30 degrees. So that means a half is equal to cosine squared of 30 minus 1. And now you see we have plus cosine squared of 30. So bringing 1 to the left-hand side is going to be 3 halves equals to 2 cosine squared of 30. We're dividing it by 2, and that's going to be 3/4 equals to cosine squared of 30. Now we're taking the square root, and we are interested only in positive value. If you remember, this is the x value corresponding to 30 degrees angle. So this is positive anyway. And we're having cosine of 30 degrees equal to square root of 3 divided by 2, which is truly the case. So that's nice, and we can apply this formula. As you can see, just for if we know the cosine of 60, we can get to the cosine of 30. So out of cosine of 30, we can come to the cosine of 15. knowing the cosine of 15, we can move on to cosine of 7.5 and so on. So in the medieval ages, mathematicians were applying for different proposals of around Europe at universities, and they were claiming like, you know, I am the guy who can compute the value of the cosine of 1 degree, and it was like really huge achievement. Okay, so I hope it's clear. We can also apply sine of 2 alpha and tangent, of course. Otherwise, we wouldn't be using these formulas and I wouldn't be proving them. But this is one of the nicest applications. So you can kind of always decline the measure of the angle and it's getting more precise. Thanks for watching. See you guys in the next video. Bye-bye. All the best.